Hey everyone, welcome to the AI show. I am Cassie Brevu. Welcome. Thank you for hanging out with me on this Monday morning. And I realized there for a minute I had the wrong tile up. So we are actually going to be talking about Whisper. So, shh, Whisper OpenAI model is GA in Azure. That's what we're talking about. That's our title. I tried to do the Whisper thing that Seth does, but I think the radio show host voice that he has to pull it off. But so it's going to be cool. I had this demo that I've been working on, and I'm excited to show it. It shows how we can kind of start automating processes for help desk creation on the shop floor. So it was based on this blog post. So let me share my screen here and show a little bit about what we're going to be talking about. Should have had this ready. Oh, wait, let me play this. I'll play our amazing bumper while I get my screen shared. Hang on. I just love that song every time. How can you not smile when that song comes on? It's amazing. So where is everyone joining us from today? I love seeing that part of it, of where you're joining to hang out, talk about AI, what you're building, what you're doing. Talk to me. It'll be fun. So here's the blog post that I was talking about that came out a little bit ago. And it's about how we worked with Siemens to start using Azure AI services to automate help desk things. So the thing was that they had people on the shop floor, they're busy doing things, and they need to report issues when their hands are busy. So they wanted a way to report issues hands-free. So they implemented AI services, AI speech services, and I believe they use Whisper as well. This blog kind of goes over exactly how they built it. And then also using LLMs to summarize and create the fields needed to submit that ticket for processing. So basically you could say, hey, I'm having this issue, and just explain it like you would explain it to another person. It would take that speech, turn it into text, post it to an LLM that would then format it and push it to their ticketing system and route it to the right person. So huge time savings, and definitely a process improvement in a cool way that people can use LLMs to start building this out. And so when I went in this and I'm like, well, how would I build it based on what they said in the service? And it really did not take that long to build. It was pretty interesting. Like getting the prompt right was pretty easy for the LLM. And then also I was playing with different services. So I was playing with both our speech to text service and our Whisper service. And I ran into something I think many people run into when they start to like play with these things. So which one do you use, right? We have two speech services. Do I use a Whisper model deployment in AI Studio? There's also different sizes of the Whisper model from tiny to large, which I think I can show in the OpenAI Whisper model. There we go. And we can look at the different sizes. I believe it shows it, not on the model card. I think it's in their GitHub where they show this. There it is. Okay, so here's the different sizes that they have of the Whisper model. And basically, the bigger the model, the more accurate it's going to be. But the smaller the model, you can run it multiple places. For example, like Tiny, you can actually run locally on like in a Raspberry Pi. I haven't tried small. You might be able to run small as well, but Tiny's really quick and easy to run locally, and you can use something like Onyx Runtime in the language of your choice to run that piece. So that's kind of a cool thing about the Whisper model is you have all those features there. If you want to start doing batching and that type of stuff and real-time streaming, that's where you can do it with that Whisper for sure, but you have to do a lot of that work yourself, where if you're using the speech service, it has all that built in and you can just use it straight from the SDK. So there's actually reasons to use both. I think in the Siemens situation, they actually did use both for different purposes because they were definitely doing real-time streaming. And the implementation that I'm going to show you today, we're not doing real-time streaming. We are just going to be posting clips of audio that I recorded and then I post to Whisper, and then it will process that. Okay. So let's jump in to how we're doing this. So the first thing I did when I started thinking about how am I going to build this, I of course went to our documentation and started looking at the speech to text service and how I can start using their SDK. So I really just took mainly what they have here, but I think there's a Python. Where's the language? There it is. I used Python first. But that's nice, obviously, with the cognitive services, you can use whichever language you want. And then I went in here and I looked at how they're calling the speech to text service. So we're using the SDK. It's going to do real-time streaming. And then, but you can also send in a file. You can do both. And then we're just going to run it. So I'm going to go to my notebook that I have for this. Wrong one. This is the one that I want. And so the first thing I did is like, well, I'm just going to start playing around with this in a notebook and see which service I want. And then to do that, I had to deploy. So I made this speech service in Azure. And then I also deployed the Azure OpenAI Whisper model in AI Studio. So in AI Studio, we can go to the model catalog. We can look at the available ones. And then if we look for Whisper, I feel like I just like Whisper every time, right? I should. That's the appropriate pronunciation. Okay, so it looks like we have large and large V3. So to deploy this, I literally just went here and I clicked deploy real-time endpoint. And then it sets up the entire thing for you. And then it also shows you the sample input that you need for posting to that. And then the sample output. So it's really super easy to deploy a model in the catalog, similar to just spinning up a cognitive service. It's also labeled for speech recognition. So I think in the catalog, you can even start looking at just what speech recognition models do I have. Let's see, we do that. And it's the Whisper one. So if you came here and you didn't know which model was a speech recognition model, you can use these filters over here to kind of find what model for the task that you're trying to solve. So I deployed this model. And then when I go back to my project, in deployments, you can see that it created this endpoint for me. And so this is the endpoint I'm going to be playing with that you're going to be looking at when we post to the OpenAI deployment on Azure. So then for the speech to text model, I spun up like any other resource in Azure. I just went and looked for the right service and then hit deploy, set up your region, all the normal stuff, just like setting up any resource. And then you get your resource with your endpoint and key. This one has a speech studio, which I have not played with much, but I think this might be useful for probably figuring out different use cases, trying them out. So it looks like you can try live chat avatar. That looks cool. Oh, I'm not in the right region. Okay. But basically, you can try out different services here and see what works. So we have speech to text. So that's what we're doing. Try out real-time speech text. And then batch tests. They actually talk a little bit in the blog post as well about when to use what model. Batching, it seemed like it was saying that it might be better for, where did it say? OpenAI? Where did that go? Or it's saying the AI speech. Okay, so it's saying that the speech to text service is going to be better for batching. It looks like this is for streaming. But yeah, you really can do both things with both, and you can test them both out and then see which one works better for you. One thing that I like that I did when I was using the Whisper model, the Whisper Tiny model, is you could use the tiny model and get faster results locally. And then, but simultaneously post up to your service in Azure with the large model and do a transcription there. So you're doing transcription twice, but you're going to get better accuracy from the larger model. So Whisper Tiny will give you a quick result locally, and then you can asynchronously update that with the more accurate transcription from the large model. So there's actually even a reason to use both in that perspective as well. So when you start thinking about what are the things you need, like, is latency really important to you? Is accuracy really important? Obviously, both are important, but what do you need first? How much do you need to put into it? What language do you want to use? The task you're trying to solve. All those different things kind of come into play when you're thinking about it. So the nice thing is that you've got options to solve your problem. So once we get past this part, or let's see, can I see? Okay, so this is where I would browse and upload a file, and then you could try it here. So you could start like on using some of your different speech services here, and see how it works as well. But I already did all that, so I'm going to just go to my notebook. And so in my notebook, I actually did it. I did both. I set up speech to text service here, and then a large model endpoint post here as well. New. And let's just go ahead and run that. So we're getting our environment variables. We're getting our region. We're running in East US. And here's my audio files. So for the audio files, I had like I think five different audio files that I just recorded. So I had like I had example text for fake. I just read them and recorded them to create my test data set here. But you would want to obviously go through the process of collecting your test data that you would need. And you could just use something random too if you want. But because we want to actually be able to pull out specific information and make sure that it's being formatted correctly for the issue post to the ticketing system, I wanted to get test data that actually represented the problem that we're solving. Let's see, and also as I'm going in the chat, I'm going to try to make sure I keep a look at that. I see Ivana's here. Hey, Ivana, good to see you. Thanks for hanging out today. My voice is a little tired today, you may notice, because I talked a lot last week at our MVP Summit, which was amazing to meet so many of our really, really amazing community. So excited to be here. It may sound a little raspy, and that's because I think I talked for an entire week straight. Okay, so then let's go back to what we were doing here. So we have the speech SDK. We're calling, we're just giving it the endpoint region. We're telling it to use microphone. So this is cool because we can say either use microphone or use audio file, right? Because the speech to text service just has that built in. You don't have to build out any sort of audio processing and things like that. So when I actually used Whisper in C# for that service, I had to build out all of my audio processing to get it to the right format, to get it to a tensor, and then post to the AI service. So there's definitely tooling there where you can do that. But with the speech to text SDK, I don't have to do that additional pre-processing before I post to my model. Okay, so we have our audio file. And then let's see here. We've set that. So we've used microphone pulse. We can also try it with. I think that should work even though I'm streaming. So we could try both. But let's do this audio file first. We're going to tell it to recognize, and then we are going to post that here. So this is now going to take that audio file, and it's going to use the service that I set up, and it's going to transcribe it here. So there you go. This is the problem. Part number ABC123. The brake motor is overheating, causing glazing on the pads. So you can see it's a very like mechanical issue, and letting them know it's what the priority it is, because that's an important piece that they need for the ticket. They need to know what it's impacting. So all these different pieces, that the part number that's having the problem. So this would be something they would just be able to now verbally say was an issue, and then we'd be able to take that text. See, because this is just the first step. The first step is getting the text. The second step is using the LLM to parse it into an actual. Try doing the microphone one too. See if we can. I think that's all I have to do for that. And then I think it'll say listening. Yep, so it says speak into your microphone. I'm speaking into my microphone. And then I don't know. I think if I just stop talking, or is it doing it now? We're going to find out. This is going to be fun. And then we do this. Yes, there you go. There was me doing live transcription with speech to text, saying, I don't know if this is going to work. I'm just going to keep talking. This is going to be fun. Twice. That's how fun it is. It is twice. This is going to be fun. Cool. So now you can see very quickly and easily with very small amount of code, I'm able to start using the speech to text service, and I don't really have to do any processing. As you saw, it's just all built in, and I can use the language of my choice, and I can start getting those transcriptions, both real time and pre-recorded. So when I was thinking about doing this too, you probably want to have some sort of activation word, or maybe they'd be able to hit a button and start talking. So you'd want to set up that piece of it, which I have not done in this particular solution yet, of how I would actually activate the speech to text piece. You could also do full, post full audio. So maybe you want them to hit a button, record, and then hit another button, and then post. And then you're just, instead of doing the streaming with the microphone, you're doing it like I have it here, where we just have this file and I'm posting it. So there's all types of way that you could also figure out how you want to get that text and display it in the service. So lots of decisions to make when thinking about the requirements that you need. Any questions yet? Anyone have any thoughts on speech to text? Has anyone used it, liked it, had issues with it? Tell me all about it. Okay, so now we're going to look at the OpenAI Azure AI service that we posted. So here you can see it's just grabbing the key and the endpoint, and we're just posting to the endpoint. It's literally it. Did I set my, where did I set my information though? Oh, up here, right. Okay, so here's the file. I was looking for my input data down here. So here's the file and the language that I'm telling it in my post. Now this is going to go to the OpenAI service, and then we'll see that same transcription from the OpenAI service that we deployed in Azure AI Studio. So let's see, from a timing perspective, let's see, we're at like 30 seconds here. That seems like it usually didn't take that long, versus this one was 10 seconds. Yeah, so it looks like Whisper Large may be a little slower. Oh, there we go. Yeah. Let's see. So I'm curious from like I want to open up a new notepad. I want to look at the two side by side here, because I'm curious, like from an accuracy. If you want to do a diff. And I think they're both really accurate, though. When I was doing this before in testing, I didn't really see much of a difference for what we were doing. When it comes to different languages, though, I don't know about the accuracy and support for each. We should look at that first. Let's look at the different accuracy. So I know with Whisper Large, it supports different languages. So here's all the languages it supports, and then I believe this is showing the accuracy amount. Let's see. So it varies very widely depending on the language. So that's another decision, right? Like if you're needing to use a language other than English, English tends to be pretty good on both, is looking at how does the language support for each model perform, which would be another reason to think about which models to use versus OpenAI versus speech to text. Let's look what Azure speech to text language support. See if we can get a graphic on that one. 139 languages. That's amazing. That's the quick start. Maybe I do just want to click into here and let's see. So I'm curious if this is also going to show the accuracy on the different languages that it supports. Wow, so it looks like Azure speech to text might support more languages than OpenAI. Let's see. Yeah. So there's another differentiating factor between the two models and what to use. So thinking about that piece, thinking about the accuracy for different language, the supported language, and the use case makes a big difference on which model you're going to use. And I actually feel like it's always going to be kind of a combination. It's like to have the faster local, and if that's important for my use case, and then still use the cloud service. So there you go. Another thing to consider when figuring out how to translate your text. Okay, so this is the one I think I just posted, which is this is the OpenAI one, right? Yep. And here is the speech to text service. And does that work like that? Well, I probably need to diff these. Oh, this has some other, okay, this has it twice, I think. So we have text. Yeah. There we go. This one does too. So there's a little bit of a difference there. Or did it? Hang on a sec. Is that the same thing? Yeah, I need to report a problem impacting the brakes. Really should be doing a diff here. I'm not going to sit here and try to diff it, but that would be another thing to start thinking about when you are, again, figuring out which model to use, doing proper testing. So now we've got the first step done. We've started to figure out which model we want to use. We've thought about the different use cases for each model. We've started to look at how they perform on both live streaming and versus a model or a model of audio file as well. So now that we've had that piece done, and let's say we've decided to go with the, OpenAI Whisper, I think is what I ended up using. Then we can start thinking about how we're going to do our LLM processing. So let's go to my prompt flow. So this is the most simple prompt flow LLM. I don't have anything other in here other than just my prompt to take that text that we just translated and then post it to my LLM that then gives me back my formatted results. So if we look at what the prompt looks like, also is pretty simple to create. We're just saying them that you're an agent for HLP Manufacturing, which is a fictional manufacturing company. And your job is to summarize the issues reported by the field and shop floor workers. The issues will be performed. Let's do this like in wrap text. Where's my wrap text? There we go. That is much better. Yeah, so we can say, to summarize the issue reported by the field and shop floor workers. The issue reported is in long form text. And then we're telling it to summarize the issue and classify departments, or like telling it to find those pieces out. And then we're also giving it the options for classification. And then here's the key points we want. So we're putting those in bulleted lists, saying here's the pieces to pull out into bullets if they have it in the problem. And then we can include history for looping. So when you think about it, and I only iterate, I really didn't have to iterate that much before I was getting a pretty decent result. And then the input here would be whatever your text is. So I don't have an actual input here, but then the output would be that formatted result. So they're saying they didn't understand the issue because my issue is test text here. Oh, wait, but we had that. Let's put it in. Let's see. Let me grab that from here. You can see why it wouldn't understand what the issue is on that. And let's go ahead and run this. So now we're taking the text that we used from our speech to text service, we're sending it into the LLM, and we're saying, please parse it out so we could put it into our ticketing system. Suspense. Any questions so far? No, nothing. All right. Y'all are pros. This is taking a minute to run. Usually it runs faster than this. Let's see. Did it? There we go. Okay. So let's take a look at the output here. So you can see that it pulled out the synopsis here. So overheating break router causing glazing on pads. And we have the description. So this is the full description here. And then we also have the problem item. So this is our problem item number, the environmental description. So when this posts back from the when you see when we put them all together, it'll have it formatted. And this is just returning that text, and then we can post it to the thing. So then here's the sequence of events, and we can see we have 1, 2, technical priority. So what's this ticket, and what does it impact? And then, so you can see from that text, it was able to parse this out. It's hard to see here. It'll make sense when you put it together. But that's all we needed to do in order to then take free-forming text, figure out how to summarize it, and parse it out for a help desk system. So if we look at how we implemented this in Teams, so I wanted to use, we have this like Teams toolkit. Let me see if I can. Oh, that's spoilers. That was me running it earlier. Okay. We have this Teams VS Code toolkit. And so I was looking at this thing and it was like, oh, it's just a web app that I can use to start building, like all TypeScript, to start building a Teams plugin. So I was like, that's pretty cool. So I was looking at, using Node, how I could start implementing this in like a Teams format. So you would say, you would hit a button on Teams, and then you would talk to Teams, and then it would record it, and then it would kick off these services, and then give the summary results. And then you'd say, yes, that's correct. Please file a ticket or something. And then it would go off to the thing. So that was the high level of where we were trying to go with this service, but we have not got that far yet with it. So I'll show you where I'm at with the Teams service implementation. Again, you don't have to use, you could use whatever code implementation you want, because they're just endpoints at the end of the day that you're then orchestrating through whatever application you want, and then posting them. So CJ says, not so far, just watching. All right, cool. I'm glad you're following along and it's being helpful. That is amazing. Okay, so that's kind of the high level thing. So when I go to this app that I'm looking at doing with Teams, I have this Teams bot. And I believe this is the one that does the full call to whisper. So on message, so I'm saying when you message my bot, call this speech to text, and I'm calling the whisper model because I'm just posting one full file. And that was the one that I implemented. Again, you could use whichever one, requirements and the amount of coding things you need to do. With the AI Studio, I don't have to do my file. It's for the local whisper model that I have to do my pre-processing and post to the model. So I want to be clear, because I said with the whisper, you have to do that pre-processing. That's only for your local or own implementation of it in your code. With AI Studio, you don't have to do that either. So if you're deploying an AI Studio, or if you're deploying with speech to text, you don't have to do any pre-processing. You can just post your file. But if you're doing local, that's where you have to start doing a little bit of the pre-processing to get it to work. Okay, so we're calling the whisper speech to text service, and then we're calling the process ticket here. And this process ticket is what's going to be sending to the LLM that we just saw, which is using 3.5 Turbo. So in order to deploy that service to process this ticket, let me go back to AI Studio. So the prompt flow that I have for HLP manufacturing, I just pushed that prompt flow to our AI Studio, and then use the deployment functions within here. I do have code as well to push that. So I think I have, oh, wrong one. You can use the prompt flow SDK to push the prompt flow that you created locally to Azure. So you don't have to kind of manually upload it. So that's what we did here. And then you can navigate to Studio to deploy, or you can also set up GitHub Actions to deploy using the endpoints, the same ones that it's the same endpoints. You can even use the Azure, the AZ ML extension. All right, so we now, oh, let me go back to AI Studio. So you saw this, and then we created our deployment. And so now our deployment for HLP manufacturing is right here. So here's my ticket processing endpoint, and here's my Whisper OpenAI endpoint. So these are the two that I'm going to be using, that I decided to use in this particular solution based on the requirements that I had. So now that I have my deployments, all I have to do is wire it up. So that's what I'm doing here on message. I'm going to call my speech to text, and then I'm going to process the ticket. And then right now I'm just posting that back to the teams. So let's take a look at that piece next. Or if you, I don't know if you want to see the code to implement the services that I created. It's just posting, so it's not really anything interesting code. And then in the Whisper text, same thing, just putting together my data and posting to the URL. So nothing super interesting or difficult there. And then cool. So let's go ahead and run this. We're going to run this as our Teams app with Node. So you can see how quickly, like if I think about the whole end to end on this, it was actually pretty quick to get set up. Like there was a few things, that I spun on to try to decide what service to use and things like that. But the overall process is really simple. Let's say process my audio file. So this is that same audio file we were using in the notebook. And I just have it set up in blob storage. And I do have some other ones too. Maybe we can update those and test it out a bit. So the first thing it's going to do is take the audio file. It is going to post it to my Whisper endpoint in Azure OpenAI. And then I'm going to get back that response. And then I'm going to send it to my prompt flow, who's going to use the 3.5 Turbo LLM to parse out the information and get it ready for my ticketing system. So you can see, so like one of the things I've needed to figure out, okay, so here's our text that came back and here's our processed information. And one of the things I want to still do is I want to, like, how in Teams you have options to like record and different things. So I would like to add that piece in here. So you could have like a little recording button to record your issue or upload a recording. But I think from a user perspective, it'd be better just to hit record and record your ticket issue. So there you go. This was our ticket. I need to open a problem report for part number ABC123. Brake router is overheating, causing glazing on the pads. Temperature, it's after 3 or 4 laps when the driver is braking late and aggressively into corners. Is this a user error? I'm just kidding. I guess you got to account for all those late and aggressive braking scenarios. Stress testing. They're stress testing it. Total makes sense. So it has the severity prioritized and what it's impacting. And then here is how that was parsed out. So we have our ticket processed. Here's the the header. So this is probably like the title of your ticket. The description, again, the problem item. So we could have that, the environmental design part of it, which is the issue observed with when the temperature is above 24 degrees Celsius. Don't know what that is Fahrenheit, but, and the driver is braking aggressively into corners after 3 or 4 laps. So the sequence of events, it has that parsed out as well from the, you can see the driver brakes aggressively into corners, causing the brakes to overheat, resulting in glazing, technical priority, impacting the brake assembly, and then the severity rating. So this said it's not mentioned. I thought it was. Yeah. Oh, we found an issue. Severity rating is not mentioned, but the issue severity is priority 2. Interesting. Let's try hitting it again and see if it doesn't, because I swear it was getting all my stuff. Process my audio. This will just, I could literally say anything. I could say blah and it would do it, because I just have it saying like on message, do this on every message. But you would change that into like on, file post or whatever. I'm going to take a little sip of water while my AI processes. But that's interesting. So this is something that maybe we would need to look back at our LLM. We'd want to do evaluations. So something I've not done on this at all is setting up evaluations for groundedness, relevance, and fluency. And so something before I would ever just say, hey, this is good to go, is I would need to set up those evaluations with some test data, more than 5 files as well. And then see if I would start getting good results. Okay, so actually this result was better. And it broke out my sequence of events into 1, 2, 3, which is actually, we saw 2 when we ran it in VS Code, and we just ran the prompt flow with the text. This is what we want to see when we see the severity rating. So we can see that it got it right the second time. So one thing that I think is interesting about these too, so when you start doing evaluations and you start seeing how it's performing on large sets of data and finding issues, because there's always ways to kind of look at things and break them out and try to solve for the ways that it's performing. You can also see that like I didn't change anything and I got a better result the second time. So it's interesting. Another thing you can do right now, it's still kind of expensive, but I'm hoping to get better. But like you could take this result, basically this first result that didn't have the severity rating, right? And it had the sequence of events, but it had a comma delimited, and maybe I'd prefer to have it, in 1, 2, 3. That part's not as big of a deal, but this one right here is we want that captured. So what you could do is you could actually, when you get your inference result back, you can evaluate how good it is. And if it's like below a certain threshold, you can ask the model to try again. So you could actually start to do evaluations in real time to get a good result. Because as you can see, like I didn't actually need to change anything in my LLM to go from okay to better. But also in your scenario, this is a big thing with machine learning development versus traditional development. It's not always true or false. It's good enough, right? Like you can't always say that it's going to just be, it's always going to be correct. You're always going to get the right thing. You have to get to a point where you're like, this model is performing good enough. So maybe this result is good enough because, this would get routed as a ticket and, we'd attach the audio file, and then the person that gets the ticket would maybe listen to the audio file if they wanted to and see, oh, I see they did have this, or they post it back saying, hey, what's the thing? So you can see how it still can improve process. And this is still not 100% accurate. There's different ways to mitigate that. And then you just have to decide how you want to solve that. And it also could be that I just need to do a few more evaluations, and I could probably update my prompt to also get more consistent results. But either way, this works pretty well. And those are kind of just different design decisions that you make when you're going through it. Also, different evaluation pieces. Do you want to do retries? How many do you want to evaluate as you're going along? How do I want to implement my evaluations? So there's a lot of cool things. And I think one of the really powerful things, though, is to make sure that you're evaluating, finding issues, and solving for them before you put these into production. So any questions yet on that. Does anybody want to see what some of these GitHub actions look like? I could show them. We have this in the Katoso chat, which you've probably seen. I think Seth has been showing that a little bit. We have all the GitHub actions set up in that particular repo, where you can see how you can start automating this. You can also automate evaluations in there as well. So every time you checked in a change, you can have it run evaluations and give information based on the changes that you made, kind of like unit testings or acceptance testings. So lots of things to think about when you start bringing these models to production. But if we don't have any questions, then I might just end there, because I've gone over the full process of how you think about which speech to text to look at, how you build your LLM, how you can deploy those with AI Studio, and then how I can implement them into the system of my choice, and start evaluating them as well. So I didn't show the evaluation stuff, but that's things that you can use. And if you go to so AI Studio has built-in evaluations, but if you want to do them locally, you can also go to chat GitHub, the sample, which has bunch of evaluations. Honestly, there's so many evaluations in here. It's a little bit overwhelming, but I just kept updating and doing new ones. So in here, you can see we have different evaluations for local, for pushing your evaluations to cloud, and how you can start thinking about that. And also it has the actual prompt. Since we're using GPT-4 to test 3.5 Turbo, we aren't giving it ground truth of how it should perform. So if we go to like the groundedness one, and you go to the Jinja, you can see this is how we're telling it how to think about groundedness, and giving it some examples. All right. Well, I think that is where we will end today then. Thanks so much for hanging out with me. We talked a lot about how you can start thinking about process automation with LLMs, and with using different audio speech recognition services, whether it be speech to text or Azure OpenAI. Both have amazing features and capabilities, and it's just about finding the right one for your task. So thanks, and we'll see you next week. See, what are we talking about next week? Let's look. So we are going to be looking at advancing the LLM ops, which I prefer to call them ops, because LLM ops, it's hard to say, maturity model with Azure AI. So be sure to hang out with us next week and learn more about LLM ops. See you next time. Bye.